to my channel. This is Leo, and let's do some more Leetcode today. So today's problem is all path from source to target. So it includes all path. Well, this looks like something backtracking to me. Okay, let's take a look. So given a directed acyclic graph of n nodes, labeled from 0 to n minus 1, find all possible paths from node 0 to node n minus 1 and return them in any order. So we were asked to find the all possible path to go from the starting point to the final point. Okay, so the graph is given as follows. Graph I is a list of all nodes you can visit from the node I, which means there's a directed edge coming from node I to node graph ij. So that's basically everything in this graph I list. Okay, let's take a look. So the starting point is obviously 0, and we're going this way to 1, and then this way to 3. This is one path. The other one is we go to node 2 and then go to node 3. Okay, so in total there are 2 paths. So we should return the path 0, 1, 3, 0, 2, 3. Okay, and for this one, we're also starting from 0, and the final point is 4. So the first path is 0 to 4, then 0, 3, 4, then 0, 1, 3, 4, 0, 1, 2, 3, 4, or maybe this way, 0, 1, 4. Okay, how do we solve this problem? Okay, I'm sorry, I have to wipe this out. Okay, yeah, it's going. How do we think of this problem? This looks like a typical backtracking. So by backtracking, I mean there's a multiple valid path starting from 0, and we try each one at one time. So the first choice, we go this way, and we make decisions based on this selection. So there's only one path leading to the next node, so we're going this way. Okay, when this node is the final node, we're going to add this path to our resulting list. Also, we're backtracking, so we have this result and we backtrack. We go back to 1. Is there any other path? No. So we go back. And is there any other path? Yes, we have 2. So this time we add 2 to our current path and go from there. Okay, so let's do the code itself. First, we're gonna need this, the final result, and along the path we need a container of each path. So I'm gonna just call it path. It's also gonna be a new array list. And the first node we're gonna add to every path is 0. Okay, so we have to add 0 in it. And then we do the backtrack. What do we need? We need 0, we need the path, we need the result, and also we need the graph. Okay, now we can return the result. All right, and the backtracking, we don't want it to return anything, so it's a void function. Backtrack, so it's integer start, list of integer called path, and list of integer called result, and integer matrix graph. Okay. So in a typical backtracking function, what do we do in the first place? We find the termination condition. Okay, so when it reaches to the target, okay, so what is the target? The n minus 1 is the target, right? So if this equals to graph dot length minus 1, that means the n minus 1th point. Okay, We add the current path to the result. New array list path. Okay. And what do we do in each of our selections? We choose from each path of the current node. So we're gonna do this like neighbor, graph, start. For all the neighboring points, we're going to do the DFS. First, we have to add it to our current path. So a path.add neighbor, and then we do the backtracking. After that, when it reaches to the end of this backtracking, we go back. So we will delete this. I'm going to remove path dot, it's like a size -1. We remove the last point we added here. So the backtracking, it's also the starting point. The starting point is the neighbor node, and it's also the same path, also the result, and also the original graph. Okay, let's take a look. Okay, it passes. And let's do the complexity analysis. So the time complexity, if we only have 2 nodes, we will have only one path. And if we have 1, 2, 3 nodes, we will have 1, 2, or 1. So this is one path, and the other one is from here. So there will be 2 paths. And if there are 4 nodes, the maximum path it can go is 1, 2, 3, 4. So it goes like this. It doubles. After a certain calculation, we can say it's 2 to the nth power. Okay? And each time when we're building this path, we have to traverse at least, at most, n-2 points. Okay, so we should time it by n. And as for the space complexity, we have our list, so we at least have this path. So it at least includes all of the nodes in here. So it should be ON, okay? All right, it passes. So thanks for watching. I'll see you in our next video.